moving from Mumbai to Delhi. Okay, so I will be crossing a couple of locations, like I'll be crossing Surat, Vadodara, Ahmedabad, Jaipur, and then reaching Delhi kind of location. So between these locations, every 150 kilometers, I will see difference in the weather pattern or maybe a climate. Okay, it will be a momentary also, or it could be a for a longer period also, depending upon how the weather is behaving at that particular location. Okay, so with respect to that, we need to understand weather and meteorology. As of now, with the drone operations, since we are only limited our operations with respect to the VLOS conditions, but from a longer perspective, when we'll be flying drones for a longer period, longer distances, weather and meteorology will be playing major role into it. Okay. For example, if I am flying a drone from Mumbai to Surat or Mumbai to Daman or maybe Mumbai to Igatpuri also in that scenario, or maybe Mumbai to Pune. So I should know, see, sitting here in Mumbai, I should know what is the what is the climate available at that location, how the climate is there, how it will impact my flying device, okay, the aircraft, the drone, or maybe a hybrid drone. In case I am doing those kind of, as of now, this will not play a major role apart from current scenario where we are flying the drone under VLOS condition, which is within the range of 1 kilometer, 2 kilometer, or max 3 kilometers. Okay, till the time I can see the drone. In that 3 kilometer range, there will be not major change in the weather. Okay, it will be more or less same. But when we are extending our flying from one location to another location, could be more than 50, 40 kilometers or 100 kilometers, then the temperature, pressure, your humidity, density, all these things will also come into the picture. Like for example, if I'm a pilot of a commercial aeroplane, I am flying from Mumbai to Delhi. I need to know what is the weather at Surat. I need to know what is the weather at Vadodara. I need to know what is weather at Ahmedabad or maybe Jaipur, and then finally at Delhi location. So as a pilot, prior to my flying, I need to have those information available with me, and then I should have some plan. Like if I know that okay, it is raining in Ahmedabad, so I should know like what is that way I should fly, or what is that I can do, okay, or what all things I need to take care of in case of any extremities of weather or all things. Sometimes because of the heavy rain and all the things, we may have to divert our flight, or we may have to do an emergency landing or something like that, and then later on maybe flying, or maybe we have to change the altitude also of flying. So accordingly, we have to take the call. We have to take the inputs from ATC or the weather reports and all that thing. So with respect to that, I should be pre-planned with whatever plans I need to follow in the case of it. So normally, like for example, I'm flying from Mumbai to Kolkata. So Mumbai to Kolkata is longitudinally different locations. Okay, if I'm flying from Mumbai to Delhi, more or less it is longitudinally same, but latitude only is changing. But if I'm flying from Mumbai to Kolkata, longitude is changing as well as latitude is also changing in that location. Okay, but whereas if I'm flying from Mumbai to Hyderabad, my latitude is more or less remaining same. Okay, plus minus here and there. But my again longitude is getting, or even from Mumbai to Chennai, I am flying. Again, my latitude and longitudes are getting changed. So again, weather patterns with for these different locations with respect to the geographical conditions will be different. So I need to understand how weather is behaving at that particular location. I need to have reports. I need to find the reports. I should able to read the reports. I should able to read the weather data what is being provided to us. Okay. So before that, we just understand. Let's understand how weather is there. Okay. So atmosphere is a layer of gas that envelops a planet. So our Earth as a planet, it is enveloped with the atmosphere. Atmosphere means what? These are all gases, layer of gases. Different gases are there, like it could be oxygen, nitrogen, carbon dioxide, hydrogen. All these gases are available in the atmosphere. Okay, nitrogen to be more highest number. As atmosphere is the layer of gases that envelops the planet, Earth atmosphere varies vertically and okay, Earth atmospheres varies vertically and horizontally in parameters like pressure, temperature, humidity, and density. So these are the four parameters which will vary vertically as well as horizontally around the Earth atmosphere. So if you see from the ground till 0 to 12 degree, 12 kilometers, 12 to 18 kilometers is what is we called as troposphere. Okay, this is the location in which our hot air balloons, our commercial aeroplanes, all these are flying. Okay. Beyond troposphere, we'll have something called stratosphere. Now stratosphere starts from 11 kilometers till 50 kilometers. Okay, this is where, like, if you see in the troposphere, your temperature starts with 15 degree and it can go up to minus 56.5 degrees. Okay, so your temperature in this troposphere is dropping. So as you climb higher and higher, your temperature will drop. Understand this thing, like that is why we go to hill station, right? At hill station, the temperature compared to the Mumbai city, or like if you go to Lonavala, or you go to Mahabaleshwar location, or even you go to Uti, Kodaikanal, or any higher latitude hill stations, right? Your temperature will be lower compared to the temperature at what was there at the sea level. Say, like for example, Mumbai normal temperature would be 15 degree. So if I go to Lonavala, it could be somewhere around let's say 13 degree. If I go to Mahabaleshwar, it may be 11 degree. So I'll feel always cooler. That's why we always go to hill station when we are going on vacations or on leave. Okay, so your temperature drops as you climb the altitude. So in troposphere from 0 to 12 or 18 kilometers, your temperature vary from 15 degree to minus 56.5 degrees. Okay, so higher you climb, it will become more and more colder. Okay, beyond troposphere, it will be stratosphere, which starts from 11 kilometers to 50 kilometers. In this, the temperature again will vary, but it will not be colder. It will vary from within that range, that is minus 56 degrees to 2.5 degrees. Okay, so there will be little bit warmer compared to the troposphere. Okay, so your temperature will be from minus 56 till, so it will become warmer. Okay, again in mesosphere, the temperature will vary from that is from 40 to 50 kilometers. It will go up to 80-85 kilometers. It will be minus 2 to again minus 86.5 degrees. But in thermosphere, if you see from minus 86.5, the temperature will become warmer over here. Okay, so it will be even higher temperature, 12 point, because here your atmosphere is becoming very, very thin. Actually, you are being actually protected by the atmosphere. That's why you cannot feel that much heat or those radiations from the sun. But as you climb above the exospheres and all, so you will see there is a temperature of 1200 degrees Celsius in this. And this is the layer where actually your spaceships or even your Starlink satellites or your International Space Station, all those satellites, all those are been moving in exospheres. Beyond exosphere, it will be like you will be completely into the space. You will be out into the space beyond the Earth's environment or Earth's atmosphere. You will be out in the space. That is how it is. So between this atmospheric level, Earth atmosphere will vary vertically and horizontally in parameter of pressure, temperature, humidity, and density. So our operations will be more or less will be always in tropospheres. Okay? Tropospheres only. Some drones are, I mean, those fixed wing drones may go up to stratosphere also. Okay, depending upon the capacity. So they can go up to like 18,000 feet, 20,000 feet also. So what is weather? Weather is the state of atmosphere describing, for example, the degree to which it is hot or cold, wet or dry, calm or stormy, clear or cloudy. So normally whenever we ask to describe the weather, like right now I may describe, okay, the weather is little bit hot, it is little bit cloudy, not clear, because you can see outside, you can't hardly see, like you can't see even see sun right now. If you see outside of your window, you will see that you are not able to see the sun. It is bright, but it is hot, but it is cloudy. Okay, not clear. Like you can't see very far. You can see if you are staying in a high-rise building, you will see that you can't see normally whatever the buildings, which far buildings which you are able to see, you are not able to see now. So weather is one factor in modern aviation over which man has no control. Though we have so much historical data available with us, like we have almost 100 200 years of data available, all our weather stations, wherever we have a weather station, those weather stations will at least be established at least 100 years old. Okay, like you do you know where we have weather stations in Mumbai? Any idea?
Yes, Colaba and Santa Cruz.
Yes, Kulaba and Santa Cruz, these are the two locations where we have weather stations associated, and they keep on giving regularly inputs about the weather for Mumbai locations. Okay, so these two locations are not established today or yesterday. Okay, they have been almost more than 100 years past they have been set up. Even most of the weather stations have been set up by in British era itself. Okay, so you see there are weather stations which are been almost more than 150 years we have. So our central weather station or weather location is in Pune. Okay, we have there is a university where actually they continuously monitor and they collect all the data from all other locations, and then they collaborate and promote or provide all the data to MET, that is uh, Meteorological Department. Okay, so or IMD, India Meteorological Department. So meteorological is a branch of atmospheric science which includes atmospheric chemistry and atmospheric physics, which is a major focus on weather forecasting. So a lot of time you would have heard that okay, even yesterday I was seeing the news. It was told that next 3 4 days it is going to rain in Mumbai. The climate is little bit like possibly it will be rain, but then since you see the climate is cloudy, okay, it's fuzzy, but it is not really like it will going to rain. Okay, but that was the forecast yesterday. So based on the motions of the cloud, the formation of the cloud, and the temperature differences, what is happening. So if the temperature dips more, okay, there is a difference in humidity, increase in humidity, temperature is increased over here. So all these different parameters, what is getting, it will then probably it rain. Maybe in the evening it will rain. Okay, to understand the meteorological hazard, their effect on aircraft, and how to minimize risks possessed by those hazards. So when why do we study meteorology? Because of the meteorology, whatever the hazards could be there or could affect my flying on the aircraft I'm flying, it could have impact. So basically, I will be putting risk the aircraft as well as people inside the aircraft. So how to reduce that risk? How do I forecast what could be the challenges I could having it? So, and what are the possible options, like whether I have an alternate route or I may have to delay. Like, for example, I will tell you last year, I was actually going to Chennai for my medium class training. I was sitting in aeroplane. I was somewhere, my flight was around 4:30, okay, Chennai flight. And I was sitting airport. We almost boarded the airplane. We were sitting and we were seventh on the runway. And all of a sudden, the climate got changed. All of a sudden, I mean, it was not expected. Nobody not thought about that there could be a such kind of drastic change. This is the same day I'm talking about when there was a big hoarding which was fall in the Ghatkopar area. Okay, I think everybody must have heard about that news, right? A couple of people got killed on that day. So that day, I was sitting in the aircraft. I was actually about to go to Chennai, and all of a sudden the rain started. Our flight was delayed by almost 1.5 hours. So we were simply idly sitting in the craft, waiting for our turn. ATC has shut down the runway, and they were asked all people to hold their flights. So almost 1.5 hours, our flight was delayed. We were supposed to land in Chennai by 7. We landed at 9. Okay, so it was almost 2 hours of delay. 9 o'clock we landed in Chennai. We didn't have any problem. We landed safely. Everything was good, but unfortunately, we could not reach the place because we have not done the hotel booking. We planned that we'll reach Chennai and we'll go and search for hotel, but unfortunately, we reached late, so we could not get the hotel on time. And that is the time when the IPL was also going on, and there were some matches in Chennai. We really could not get the hotel that point in time, so we have to stay for 3 days in one particular hotel, and then again in the last 2 days we have to stay in another hotel. So that is how we need to plan. But this is all can impact. It is not. It is only of my experience I'm telling, but there would be a lot of people who would have got this kind of experience and they could have got impacted because of the weather. Okay, a lot of times, like recent times, what was that? Rain was happening and their flights were got delayed. People's flights from currently war situations also. A lot of flights are now getting diverted to Mumbai rather, because the complete airspace is being completely blocked nowadays because of the war. So war is a different thing, but because of the weather also, a lot of time, all of a sudden Gujarat will face cloudy and there is a rain happening. So Ahmedabad, lot of Ahmedabad, Surat, Vadodara air traffic are diverted to Mumbai location or a Dhule location or Nagpur location or Nasik location also. Okay, or maybe Pune location, nearby airports. And then later on they are being transferred and all this. So we need to, like, for example, when I am flying from Mumbai to Delhi, lot of time I see the turbulence in Jaipur region. Okay, so that time ATC will always tell the pilot that okay, either you have to descend or you have to gain the height. Okay, from 15,000 feet you may have to go to 20,000 feet. So that way, how the corrections would be given, or you may have to go on a left side or a right side of the turbulent area also. So to identify weather information that is required for each flight to interpret actual and forecast weather condition for documentation provided, to analyze and evaluate weather information before flight and in flight. So before your flight takes over, it is a job of a pilot to analyze the weather on his flight plan. So he will normally see what is the weather pattern over his flight plan for next 4 5 hours, whatever the duration of his flight would be there. Like if it is a longer flight, probably somebody flying from UK to Sydney, then he may have to see it for a longer time. Like for example, if I'm flying from Mumbai to Delhi, so it is just a 2 hour, 2.5 hours flight. So I may have to see a weather pattern of next 4 hours max. A knowledge of a meteorology will at least enable aviator to anticipate some of the difficulties which weather may cause. Okay, so based on whatever the reports or whatever the forecasts are happening, we can at least anticipate and get ready for those kind of difficulties, and then we can be always see what best we can do at that point in time. Whether we want to divert the flight, whether we want to delay. Like lot of time, there is a huge like let's say for example Delhi, there is a huge cloud and all. Even Chennai also, a lot of time you see a lot of this. So a lot of time the flights are not being taken off from Mumbai also. They will delay. Okay, so they will delay, wait for getting a clearance from those locations, and then only the flights are being taken off, sir, because they know by the time they reach Chennai or maybe reach Delhi location or a Kolkata region, if that climate of those locations are not suitable for landing and all the things, they may not. They will intimate other FIR regions saying that okay, this is the current weather, and if possibly you have to delay your flights until unless they don't get go ahead, they will not fly the aeroplanes from the source locations. Okay, so there is something called as METAR. Okay, so the letter METAR stands for Meteorological Aerodrome Report. The METAR gives us the required data such as wind direction, wind speed, etc. needed for safe flying. The drone operation, we need to cross check the METAR for safe and secure operation where we don't risk the drones. So if the drone we are flying, wherever location we are flying, see uh, normally your METAR is related to the airports. Okay, so we do not have as of now specific METAR for the drone location. Like for example, I am flying a drone in Igatpuri, so I will not have a METAR for Igatpuri location, but then I will try to find out what is the nearest airport to that location. Okay, but again, if you see, with respect to, as I told you, Igatpuri is almost 150 kilometers or 200 kilometers away from Nasik airport. So even whatever the report I see of Nasik airport, it really doesn't matters for me, because it will be a lot of variations will be there in the climate. Like for example, if I am trying to see a Mumbai METAR and I try to compare with the Pune location, it will be a different. So at least maybe in a range of like 40 kilometers or 50 kilometers, I can refer that METAR. But if it is not within that range, then that METAR is no use for me. Okay, only for a reference, or maybe you can use three, four locations within that area. If you can find more metals, then probably you can correlate and find and come to a conclusion that what could be the weather at that location. But again, the weather of that location will differ with respect to the height, the horizontally as well as vertically. That is what we said in the first slide, that uh, we said what Earth atmosphere varies vertically and horizontally in parameters: pressure, temperature, humidity. So whatever the pressure, temperature, humidity, and density you have at Nasik city or Nasik airport, it's not necessary at Igatpuri it will be same. Igatpuri again will be a different thing, because it will vary. The distance from Nasik to Igatpuri is almost 150 kilometers. Okay, so definitely you will have a different weather pattern at that location. So you cannot compare Nasik with Igatpuri or Mumbai with Igatpuri at those locations, because both are almost 150 kilometers away from each other. Okay, so let's see now what METAR. Now, if I want to know the METAR, like let's see, I will show you the METAR for Mumbai. How do you see? Okay, so I say METAR for Mumbai. earlier the METAR was available in a one liner. Okay, it was a one liner where you need to interpret what is METAR. Okay, this is what is METAR. I'll show you what is METAR means. Okay, this statement what you see, this is actually the METAR. This is been taught to the pilot to read. Okay, if like for example first PABP, this is basically a station ID for Mumbai Airport. Okay, but nowadays you don't need to read these lines. You need to see here. Okay, it is available on the website. What is the report was made at 27 minutes ago. Okay, Mumbai, India, Chhatrapati Shivaji International Airport, Mumbai, India. Latitude is 19 degree, longitude is 72 degree. Elevation is 8 meters. So from the sea level, your Chhatrapati Shivaji International Airport is at 8 meters. Yesterday I was talking about, right? So it is 8 meters. Now the wind speed at the Chhatrapati Shivaji International Airport is 9 knots from west to northwest. From northwest, north side or west northwest side, the winds are flowing at 9 knots. Temperature is currently 31 degree. Humidity is 68 degree. Pressure is 1066 hectopascal. Visibility is 4,500 meters. That is 4.5 kilometer. You have a visibility. You can see scattered clouds at 2,500 feet. Few clouds at height of 3,000. Okay, cumulus nimbus type of cloud, and there is a haze in the sky. Okay, so you are not. So your visibility is limited to 4,500 meters. That means it is 4.5 kilometers. You are limited to your visibility. So whatever you are seeing here, it is this. Okay, so you can see 4,500. Okay, night. Then you can see scattered few clouds. Okay, then 31 and 24. This is basically your temperature. Okay, and then this is your pressure 1006. Okay, 106 hectopascal, and last it is saying no significant. I mean, there is nothing much to talk about. It is a simple basic weather. There is nothing much special thing about the current weather scene. So whatever it is written here is mentioned. Okay. Now if I want to see the same pattern of the weather, let's see now other one. Okay, I will search for METAR Surat. Now Surat has little bit different way of putting it. So same thing is there, but only better way. They have put it little bit more pictorial. Okay. So Metar or the station ID is Vasu. Okay. MVFR. Few clouds. 33-degree temperature is there. Wind is flowing little bit higher. That is at 12 knots. Visibility here. See the visibility is 6 kilometers. There is not much cloud over here, right? And then even the atmospheric pressure is 1006 hectopascal. So it is pretty clear, not much what we say compared to Mumbai. It is very clear sky. Okay, few clouds are there. Temperature is little bit high. Wind is also flowing at a very high rate. You can, but still you have a good visibility here. Yeah, in Mumbai it was talking about 4,500 meters. That is 4.5 kilometers. Whereas in Surat, the visibility is 6 kilometers. Okay. Again, let's see about Delhi. So normally we, as a we always regularly see the METAR report over here. Okay. So now Mumbai. After Mumbai, you see Indira Gandhi International Airport, New Delhi, India. Latitude is 28 degrees. Okay. Longitude is 77. Elevation, see now, 220 meters. Okay. So it is very high compared to Mumbai. Okay. Mumbai was just 8 meters from the sea level, whereas this is 220 meters high. Okay, so definitely if you see the temperature right now, it's very high at Delhi, that is 42 degree, whereas compared to Mumbai it was just 32. So 10-degree difference is there, but humidity is very less. Okay, here humidity is very high, that's why we sweat. Okay, the humidity was 66 percentage, whereas here humidity is 17 percentage only. So here humidity will be very less. So what will have, it will be a dry hot hot wind, hot air. Okay, dry hot air. Whereas pressure is more or less same 1002 hectopascal, but visibility here is 5 kilometers. Okay, few scattered clouds at 3,500, few clouds at 4,000. Similar type of visibility is there in Delhi also. Okay, so this is how actually your METAR we used to send earlier. So this was actually earlier was sent to ATC, like how you get short messages. So earlier this METEOR was visible to the pilots in this form only. And based on this information, they have to interpret what could be the climate or what could be the weather condition at that particular location. Okay, nowadays because of the technology involvement and you are having a website for all the locations, you can have much better and easier readable format meta reports available. And then if you see on the middle part, these are forecasts. Okay, this is current weather observation as of now. Okay, maybe 31 minutes ago, what was the condition? This is forecast for next 4 hours. Okay, report was made 4 hours 30 minutes. This is forecast for next forecast valid for from 1600 hours to 1700 at 12 UTC. So maybe around 4 to 5 p.m. it will be valid. Okay. So what could be that? Like see difference now here. 9 knots, the wind may flow at 8 knots. Okay, these are based on the past data, historical data. They forecast this. What could be the possibility, or subsequent days they would have seen the change in the climate. Few clouds, hazy, temporary, 15 knots northwest gust, 25 knots. Okay, so maybe in between you will see all of a sudden wind flowing at a very high rate and all that things. Okay, so this is how you will interpret. Okay, so earlier this was actually the forecast was. Okay, so as of now, from a drone perspective, we don't need to understand this terminology, what is required. Only from a drone perspective, under VLOS condition, what we need to understand is most important what is the cloud, what is the visibility, and what is the wind speed. Okay, so wind speed is here 9 knots. Surat wind speed was 12 knots. So there was a very high wind. So it is little bit, I mean, above 15 knots, you are supposed to be not flying your drones. Okay. So I will tell, in subsequent slide, when we see the wind sock, you will come to know what is 15 knots. Okay. And how do you recognize 15 knots of wind speed also. So even here you see 9 knots of wind was flowing in Mumbai. So it is pretty okay to fly your drone in this condition. But moment you cross 15 knots, you are not, your OEM will suggest that not to fly your drones. Okay, because it will be a heavy wind. Any questions so far on the METAR?
Nothing from me.
No, sir.
I will be sending you the picture how to read the METAR also, and I will give you some examples which you can also try and interpret the METARs. Okay. So METAR again, let me repeat. METAR stands for Meteorological Aerodrome Report. It gives us the required data such as wind direction, wind speed, etc. needed for safe flying. The drone operation, we need to cross-check the METAR for safe and secure operation where we don't risk the drone. So, for example, if your wind is flowing more than 15 knots, you should immediately land the drone. You should not fly the drone in this condition. Okay, so METAR, lot of not only like I showed a very simpler way or easier way where you can go on those particular website for those particular location and see it. But there are currently lot of Android apps are also available like UV forecast, good to fly, drone cast, drone buddy, air data UV, windy. Okay, windy is more reliable, more accurate. That's what I have seen because I most of the apps I have used. So I have seen that windy is more, but then it is a paid software, okay, or a paid app where but you get more accurate data around it and it can forecast very well for next 7 to 10 days of data. So you can try using windy as a software for understanding the weather pattern. Okay, international standard atmospheres. Now, international standard atmosphere is a static atmospheric model of how the pressure, temperature, density, and viscosity of the Earth atmosphere change over a wide range of altitudes or elevations. Like as we have seen, like the atmosphere pressure will change from, like for example, since Mumbai is at 8 meters from the sea level, whereas Delhi was 220 meters from the sea level. So definitely there would be a change in pressure, temperature. Temperature we have seen Mumbai was showing 31 degree, Delhi was showing 42 degree. Okay, whereas density and even the viscosity or pressure, all these parameters, pressure was more or less was same, like 1006 or 1008 or 1002. There was very minor variation in the pressure as of now, but there are locations where there could be a difference in pressure. For example, if I climb to like location like Mahabaleshwar, or if I go to Uti, or if I go to Kodaikanal, those very high hilly locations or on the top of a mountain, so pressure will vary over there. So every 1,000 feet or maybe 2,000 feet, the difference in the pressure I can find out. Okay, so as you climb the altitude, the temperature will reduce as well as the pressure will also reduce. It has been established to provide a common reference for temperature and pressure and consists of a tables of values at various altitude plus some formulas by which those values were derived. So there is a table which has been prepared by ICAO, okay, which gives you for a particular location what could be the temperature, what could be the pressure, what could be the density, what could be the viscosity. All this is published in a table. So International Standard Atmosphere publish the standard atmospheric settings. So they have standardized some settings to take a benchmark or the baseline. Okay. So at mean sea level, your temperature will be always considered as 15 degrees Celsius. Okay. At mean sea level, temperature is always plus 15 degrees Celsius. At mean sea level, the pressure is always considered as 1013.25 hectopascal. Okay, at mean sea level density is 1225 grams per cubic meter, and the lapse rate from the mean sea level, okay, it will be 1.98 degree up to 1000 feet, okay, up to 11 kilometers, that is 36,000 feet. So what do you mean by the last? The last sentence is very important. As I said, give an example. Let's say at mean sea level we are considering 15-degree temperature. If I go 1000 feet up in the high, up in the air, what will happen? This 15 degree will become how much?
13 degrees.
13 degree. Furthermore 1000 feet I go up. How much it will become?
11.
11 degrees. So every 1000 feet there will be a difference of 2 degrees. Okay. So for example, if you go to Kodai Canal is 8000 feet. So what will be the temperature at Kodai Canal? So right now, let's
It
take
would
a
be negative, right?
yeah, it will.
It would be negative. -1.
This is MSL, okay, MSL temperature, okay. So like for example, currently your temperature at Mumbai is 31 degrees. So with respect to 31 degrees, what would be the temperature at Kodaikanal? 8 to the 16. So 31 minus 16.
Uh,
15 degree.
yeah, 15 degrees.
So temperature at Kodaikanal will be roughly around 15 degrees. So that's why when we go to Kodaikanal Ooty location, even though now it is summer, even in this climate, you will have a cooler temperature there because you are at that 8,000 height. Okay. Similarly, when you are flying your aeroplane, as you climb the altitude, your aeroplane is outside temperature. A lot of time you must have heard outside temperature is minus. Sometimes they tell you in minus also. Okay, so it is a temperature where even our body cannot sustain. Okay, so it is difficult to be there in outside temperature. That's why the aeroplane is completely sealed. Okay, from externally and internally also, and it is climatically accomplished to for a normal this thing for people to stay in that cabin. Okay, so it is called as a pressurized cabin. So there is a low pressure, low temperature, all that things are there outside the aeroplane. Practically, we use lapse rate as 2 degree per thousand feet for calculation up to tropo phase. Okay, so that 12 to 18 kilometers, whatever we say, within that range, every 1000 feet, there will be a difference of 2 degrees. Okay, so clear. This important. There are a couple of important points to be taken from this slide. Is MSL temperature is plus 15 degrees Celsius. MSL pressure is 1013.25 hectopascal. Okay, density is 1225 grams per cubic meters, and the lapse rate you have to consider as 2 degree per 1000 feet up to 11 kilometers. For calculation in propopoles. Now, types of pressure. Yesterday we have seen this is the same topic over here. In the aviation community, the term QNE, QNH, and QAP are used to describe the standard pressure, local altimeter, and field elevation, respectively. Okay, so field elevation, QAP. Yesterday also I told you QAP is field elevation. This is with respect to your runway. This is with respect to your ground. So QAP is the altimeter pressure setting at the takeoff location, which indicates height. So when your aeroplane is on the ground, the altimeter will be reading QAP as how much?
0.
0.
0. Okay, so it will be reading 0. as my drone or aeroplane takes up, it will be reading whatever the actual height with respect to the ground. So if it is 10 feet, it will read 10 feet. If it is 20 feet, it will read 20 feet. So that is the height with respect to the takeoff location or with respect to the ground location of that. So QFE is nothing but your field elevation or height. Okay, so remember FE is nothing but field elevation or height. Okay, whereas QNH, nautical height, QNH is the altimeter pressure setting at the takeoff location reduced to MSL. Reduce to MSL under ISA condition, which indicates altitude. Means what? It is actually considering QNH is also considering your elevation of your location. So, what is the elevation of Mumbai Airport? If I want
8
to talk
meters.
about
7 to 8 meters.
8 meters. So, if my height is 20 feet with respect to the runway, so what will be the QNH?
28.
Very good. Okay, so you are adding QFE plus the elevation. Okay, so 28 would be your QNH. But if I am flying from Mumbai to Muscat or flying Mumbai to Delhi, I am middle of the sea in the Arabian Sea. I do not have any reference point. I do not have a ground, neither I have a mean sea level. So what I will do in that scenario, I will communicate about QNE.
QNE.
QNE. Okay, so that is the altimeter pressure setting at standard atmospheric pressure. So it will indicate what is called as flight level. Okay, it is called as flight level. So whatever your altimeter would be setting at that point in time based on the pressure setting, okay, atmospheric pressure setting. The standard pressure they will set it at as 1013.2 hectopascal. So that altimeter will show you the level of flight level. So it may be 20,000 feet or maybe 10,000 feet or 15,000 feet, whatever it is showing accordingly. But then that time you have to refer saying that right now I am indicating a height of QNE because you are not following QNH or QFE. You are away from the sea level as well as you are away from the land. You are in middle of the sea. So you have to tell that QNE is my 20,000 feet. So they will understand that you are talking about flight level with respect to the standard atmospheric setting. Okay, so here again that same picture yesterday what we seen. So you see here the height QFE with respect to the aerodrome or airport. Okay, so this is your height, whereas your flight level. Okay, flight level is with respect to standard atmospheric pressure, but normal altitude with respect to the sea level. If I am close to the Mumbai Sea, okay, so what I will do is the elevation plus height will be my altitude. That is what Nishan told 28, right? So this was 20, this was 8. So 20 plus 8 is 28. So my altitude with respect to the mean sea level will be 28 feet. Clear? I hope now you are clear with the this picture and the explanation.
Yes.
Yes.
Yes, sir. Yes.
Okay, now after the pressure, wind. Wind is the most important factor which can affect your drone flying. Okay, so there is a device called anemometer. It is a device that is used to find the wind speed. So there could be two types of anemometer. One is the manual or analog uh, anemometer. It has four cups. You must have seen a lot of time near the weather stations or some old historical buildings also would have been installed anemometer on their roofs. Okay, so these anemometers are analog anemometer which are fixed, while digital anemometer are pocket size and compatible. So these are almost like costing you around 300 to 400 rupees. It is available on Amazon also. Okay, you can purchase if you want any anemometer available. So digital handheld anemometer are available in market, which a drone pilot must always carry with them to cross check the wind speed at the time of the operations. So at our flying site, we also have a anemometer available over there. Okay, the wind speed should not be more than the permitted limit by the manufacturer at the time of drone operation. So you should know what is the permitted wind speed for your particular drone. For example, our drone are not allowed to be flying above 15 knots of wind. Okay, so whenever we see that wind is flying above 15 knots, normally we'll try to, again depending upon how the conditions are there. If it is 15 or 15 and more, then probably we'll stop flying the drones. Okay, we'll land it immediately. If it is somewhere near 12 knots, 15 knots, still okay, manageable, we'll fly the drone. Okay, so a lot of time, all of a sudden between, we'll see the wind is flying more than 15 knots. Then we again need to see whether it is a long-term pattern or it is a short-term pattern of wind. Yes, Nishan.
So at the airports we see some conical shape
Right.
balloon type.
Next slide is that.
Okay.
Okay, so what you are talking about, the conical shape, that is called as windsock. Okay, it is a light, flexible cylinder or a cone mounted on a mast to show the direction and strength of the wind, especially at the airfield. Okay, airfield, aerodrome, airport, you will see this kind of a windsock. This is called as the windsock, which has 5 sections. Okay, it is a 5 sections. You can see 1, 2, 3, 4, and 5. So if only first section is horizontal and remaining 4 sections are bent, then we say the wind is blowing at 3 knots. So every section is 3 knots. So here if you see 2 sections are horizontal and 3 sections are bent, then we say 2 into 3, that is 6 knots. If you see here 3 sections are there, so 3 into 3 is 9 knots. 4, 3 4 the 12 knots. All 5 sections are horizontal. Okay, that means your wind is blowing almost maybe 15 or more knots. So if your windsock is at this condition, you should stop your drone flight. Okay, so are you clear now? Looking at the windsock, anywhere you can tell how many knots of wind is blowing. Okay, so white and orange strips on windsocks are not for decoration, they are actually indicates the relative wind speed. In absence of equipment, we can measure wind speed and direction with the use of windsock. So if you do not have an anemometer or anything like that, just by looking this basic device, you can at least gauge some wind speed. Yes, Gautam.
No, I was just wondering, this seems to be made of cloth. So if it gets wet and all, it still measures
No, not
accurately.
that, not that. It is what is that? Water resistant cloth.
Okay.
It is water like how your umbrella is made. Okay, it may look like a made of a cloth, but it's not umbrella. It is a water resistance cloth.
Okay. So it doesn't matter if it's wet or dry.
Even it is, if it rains and it's down after some time, it will get it dry immediately. The water
Okay.
will not affect on its.
Okay.
It is not a normal cloth; it's a water resistance cloth. This is also available on Amazon. Okay, so we have already purchased these wind socks, and we will be installing whenever we are flying the drones over there at our location.
Any
Okay,
particular height it has to be at?
maybe around 10 to 20 feet.
Okay.
10 feet is minimum what is required. Okay, anything above that is good for us. So we'll normally be putting it around 15 feet height at our location. So we actually have not created a fixed pole for this as of now because there are other challenges. I will let you know once you are at the site. We had made a fixed position for the pole to be fit, but there was little bit changes and the pole which we made has got underground now. Okay, so it has gone below the ground. So we have to now create a new pole again for fitting. So temporary we are fitting it on a temporary structure whenever we require for drone flying. Okay, so when you see the windsock, you should always, every time you should see your wind. So this will also change its direction on the flow. Okay, so it can change its direction. Okay, so it is a movable in all the directions. So accordingly, wherever the direction, wherever you see the cone, that is the direction in which wind is flowing. Okay, now let's see the different
What if
types.
the wind blows from the other side? How do we come to know?
This will change. The direction will change. Like for example,
Okay, it will change the direction. Okay.
okay, so imagine this as a wind cup, okay, or wind sock. So now this is in this direction. So your wind is flowing from this direction and going from back. If it is like this, so wind is flowing from this direction and going back from. So the bigger location is the in source of your wind, and the smaller conical taper location is your outsource of the wind. So that is indicating the direction of your wind.
So if the wind flows from the other direction, it will
So if,
change course.
assume now this is like this, okay,
Huh.
this position, and wind started flowing from this direction. So this will flow. This will change its direction
Okay, okay, okay.
automatically. So you will see this change in the direction also. So now since now you are equipped with this knowledge, whenever you see, you take time to see the wind sock. You will realize whatever I have told you, it will demonstrate you the direction, the speed, and all that things you will interpret. A lot of people were up till now were only seeing the lal, red and white cloth is flowing and all the thing, but nobody knows about how to read, and we never been educated for this kind of things. But now you are already been imparted that education and knowledge. So now whenever you see, wherever you see this, wherever you go, like even a lot of time we go, we travel from one location to another location. On the airport, we will see the wind stocks over there. So looking at the wind stock, now you should able to know at what speed the wind is flowing and what direction the wind is flowing. Okay, there was one movie. What was that movie? In which they have shown the Pokhran blast. Have you seen that movie?
Parmanu.
Parmanu, yes. In Parmanu, if you see the last 10 minutes where they were testing, in that point in time, they were actually seeing this anemometer and the windsock, all those devices they have been showing. They were actually seeing, because they were worried about if whenever they test, there will be nuclear radiation would be there. In what direction the radiation would flow. So they need to control that flow. They don't want that flow of radiation to happen where the people are staying or residing. So they wanted to make sure that wind is flowing in a right direction and desired direction where it will have a minimum or minimal effect on the people. So there you can, in that movie also, last 10 minutes section, you can see that the hero is actually trying to see which location the weather is flowing. In fact, earlier the weather was flowing in a Pakistan direction. So that point in time he said, no, let's wait for some time. Okay, let the weather or the wind direction get it changed, and then only after that, once the weather location, the wind location is been direction is been changed, then only he said, okay, go ahead and do the testing now. Okay, so that's how they know it, right? I think you may not have thought at that point in time when you are seeing that movie, but from that perspective, it is so important. I mean, there is a lot of good things in that movie, like even the satellites. What you see in that movie, they have shown, so you can actually see the satellites in the sky also whenever you, when you go to Igatpuri, you can see satellites from those locations also in the night sky. Okay, so let's see now types of wind. So there are a gust is a sudden increase in wind speed, often in change in direction, lasting less than 1 minute, and it's a local effect. We might have felt a lot of time this kind of gust. Okay, all of a sudden the wind will come with very high speed, change in direction, lasting less than 1 minute. Okay, so these words are very important to describe the wind. Okay, gust is a sudden increase in wind speed, often with change in direction, lasting less than 1 minute, and it is a local effect. That means if you are standing here, a person standing at 1 kilometer away may not feel the gust. Okay, so it is a very locally effect. Okay, lot of time we would have seen this in an open area, open ground. A lot of time we'll see all of a sudden the wind blowing at our location, but the other person maybe 500 meters away also we will not feel the gust. Okay, so it is lot of time this is a local effect. Whereas lull is a period without waves or wind. So there is some period after the gust, there is always a silence period. Okay, you will see that there is completely silent, no wind blowing, nothing happening. Okay, a complete period of silence. So that is called as lull. Okay. Next is squall. Squall is again sudden increase in wind speed. So gust and squall are again both same. Sudden increase in wind speed, often with change in direction, but lasting for 1 minute or more. Okay, so your gust was less than 1 minute, your squall is 1 minute or more. Okay, and this can be cover wide area. Okay, your gust was limited to the local area. Squall is for a wide area, bigger area. Okay, so you can see the squall from very far locations, like you can see in the picture, right? Squall is really important to be predicted. Carelessness on the part of a squall can result in crashes of drone and hence loss. Yes, Gautamji.
I just wanted to bring this one point. Squall normally associated with rain also, so you'll have heavy downpour.
Yes. Some depending upon how big is the squall. Yes, you're right. Okay, so especially you will see this squall when your monsoon starts. Most of the time when the monsoon starts, okay, or during monsoon period also you will see it. Even now when you go to Igatpuri location or those locations, high altitude locations, you can see squall. All of a sudden, like I'll tell you, when I gone for a last session, I started early morning and I reached there somewhere around 9:30. Okay, I was just checking into the hotel room, and by 10:30, all of a sudden the climate got changed and it started raining heavily. So it rained for almost an hour. Luckily, that first day we didn't have any flying activities, so we don't require to flying. But then, since it was raining at 10 o'clock, we said that next day our flying will start little bit early morning. So we said, okay, we'll take the call at the 7 a.m. in the morning, and we'll start flying at 8 a.m. only. Okay, we'll fly from 8 to 10, and then after 10 we'll do the breakfast. So we just delayed our breakfast to get our flying time. Okay. So squall is a sudden increase in wind speed, often with change in direction lasting for 1 minute or more and can cover wide area. So how you differentiate between squall and gust? Gust is less than 1 minute. Squall is 1 minute or more. Gust is limited only for a local location or local effect. Squall is for more wider area. Again, squall is very dangerous when you are doing drone operation. So in case you have a drone operation happening and you understand that squall is going to happen, because squall you can see it from a longer area or farther away. Okay, it is not a local effect or not a smaller location it is. So you can see the squall happening far away, so you can immediately land your drone before it really impacts your operations. Okay.
So I would just like to add, if like normally, if you see a heavy cloud approaching, it could be a squall associated with that.
Yes, yes, yes. Low lying cloud. If you see low lying cloud and all of a sudden changing, you will feel this. I like last week when I was in Igatpuri, we were able to see all these things. Students were only telling, we were asking me, yes, call hai, gust hai, hurricane hai, whatever it is. I mean, now since you are learning about weather and meteorology, automatically you will able to relate into your day-to-day experiences, right? So gale exists when the wind speed exceeds by 33 knots. So this is almost twice the normal your wind speed. Okay, your normal wind speed is 15 knots. So double the 15 knots or normal wind speed is your gale. So gale exists when wind speed exists 33 knots. Hurricane exists when it is 4 times your normal wind speed. Okay, so 15 knots is the normal wind speed what we consider a basic wind speed. Okay, hurricane exists when it is 4 times, that is 63 knots. 15 fours are 60, right? 15 fours are 60. So 4 times your normal wind speed is your 63 knots. Approximately 63 knots is your hurricane where it exists. So in this both conditions, you should never fly your drone. Okay. So are we clear on the wind? Okay.
Yes, sir.
Yes.
Right.
Yes.
Anemometer, windsock, gust, lull, squall, gale, and hurricane. Okay. Then let's see now type of clouds. Cloud is a mass of a minute water droplets or a tiny crystal of ice formed by the condensation of water vapor in free air at considerable elevations. So cloud is nothing but they are water vapors, minute water droplets or a tiny crystal of ice formed by the condensation of water vapors in free air at considerable elevation. So your cloud can be, let's say, like we saw on the METEOR, right? It was showing cloud at what it was showing, 2000 or 4000, right? 4000 feet or 7000 feet. So these are at height where you will see the clouds. Okay, as the clouds are formed at some height over the Earth's surface, they take various shapes. According to their height, expanse, density, and transparency, clouds are grouped in 4 types. Okay, these are the basic 4 types. Lot of places you will see people will combine with cirrus, cumulus. Like we have seen on the Mumbai METEOR, it was showing cumulus nimbus. Okay, cumulus nimbus means it's a combination of cumulus type cloud and nimbus type of cloud. Okay, so a lot of time you will see cirrus stratus, cumulus stratus, stratus nimbus. So this combination, but there are only 4 types of cloud. Combination of these 4 types can be the type of clouds also available. Mixture. It is called mixture. Okay. So first is cirrus. Cirrus is formed at a high altitude, that is 8,000 to 12,000 meters. They are thin, having feathery appearance. They are always white in color. So you can see the picture. They are thin, feathery appearance, they are already normally they will form at 8,000 to 12,000 meters height. Okay, whereas cumulus are little bit lower because they are heavier. Okay, so they are formed at 4,000 to 7,000 meters. They exist in patches and can be scattered here and there. They're scattered. Okay, they're scattered, and they look like a cotton wool. You can see the difference between the two types of clouds. Like feathery feature appearance, it is cirrus, and cotton like wool, or in the form of like a patches, it will be cumulus. Okay, now let's see the next type. Stratus. Stratus, they are layered clouds covering large portion of area. Okay, so they will again vary from 4,000 to 12,000 meters, but they will be covering very large area, very large area. Okay, so these are layered clouds covering large portion of the skies. These clouds are generally formed either due to loss of heat or mixing of air with a different temperature. So you will see this cloud, since we are staying near to the Mumbai. Okay, so you will see this type of clouds formation. Lot of time now it is a time you will see this type of clouds getting formation. And later on stage, as we approach June, we will start seeing nimbus clouds. Okay, but suddenly your clouds will start becoming darker and gray, black and gray. So nimbus clouds are black and gray. They form at the middle level or very near to the surface of the earth. They are extremely dense and thick, so they don't have any shape. Okay, so during monsoon you will see the entire place is being covered with the cloud. Your visibility is very low because you have nimbus cloud very close to the earth surface. Okay, and then probably as the temperature dips, humidity increases, you will see the rain start falling. Okay, so this is how the cloud will affect your location. Okay, so four types of clouds: cirrus, 8,000 to 12,000 meters, thin and feathery appearance, white in color. Cumulus will always have a little lower than cirrus, so that is 4,000 to 7,000. Exist in patches, can be scattered here and there. Cumulus looks like a cotton wool. Okay, so cotton, like fuzzy cotton, it will be seen. Whereas stratus are layered cloud covering large portion of the sky. They are formed because of mixing of heat or mixing of air with different temperatures. Wherever there is a difference, temperature difference is happening between the layers, you will see this type of clouds getting formed over there. Nimbus normally are black and gray, so these are very easy to understand. These normally you will see during the monsoon season. Okay, they form at the middle level or very near to the surface of the earth. That's why in monsoon you will see the clouds are very low, very close to the earth, and it will start raining as the temperature dips. Okay, extreme dense and thick, so they don't have any shape. Okay, so what are the weather impacts on the US operations? So because of the cloud, cloud very close, you will always have VLOS impact. Visibility less than 3 miles, you will have VLOS impact. Fog, cloud, precipitation. Okay, all these things will lead you to load on your airframe, short circuiting of electronics. Again, VLOS impact will also happen because of fog and cloud. Okay, because of icing. Okay, if you are flying your drone in a high altitude, high latitude locations, like for example, you're flying somewhere near Srinagar, or you may be flying in Ladakh like locations. Okay, so you will always see this icing effect happening on your frames. So it will impact the performance of the drone. So there was a competition last year in Ladakh where they have invited OEMs to bring their drones and test at that high altitude location and colder location. So they wanted to see which drone can sustain that particular altitude, latitude, as well as that cold temperature. Okay, so there was one company, I think, which I forgot the name of that company, but which won the competition. Even Idea Forge has also participated, and I think they came second in the competition. Okay, lightning also. Lightning is nothing but lightning drop communication due to radio frequency interference. So a lot of time during the lightning, you would have seen, if, in older days when we were using the television with the antennas. Okay, so that time when it was raining or lightning is happening, you would see a lot of time the picture on the TV used to get impacted. So that is nothing but frequency interference. Okay, radio frequency interference happening at that point in time. Even if you are listening to radio also, like AM, FM radio, that point in time, if there is a lightning happening, you will see there is a loss of signal that point in time. Okay, so that is the cause of lightning. Then wind and wind shear, loss of control, inability to return to home, mission failure. So a lot of wind shear also happen. Wind shear is nothing. all of a sudden the wind moving horizontally or vertically, up and down motions. Okay, that is what we call as wind shear. And then heavier turbulence, like moderate or greater turbulence, reduce mission durations. A lot of time we see that because of turbulence, okay, if there is a turbulence happening, we may have to call out our missions. So this is, we are talking with respect to the drone, okay. But in case of our civil airlines or aeroplane, commercial airlines, what we do is, in like turbulence, normally we will inform to the ATC that what kind of turbulence you are facing, whether you are facing moderate or severe. Then ATC will check with their data, and then they will recommend you, either you bank on the right side or a left side, or you may gain the height, okay, and fly. So that is how they will give you a correction method. So they will tell you, okay, you fly at instead of 15,000 feet, now you climb to 20,000 feet and fly for X amount of distance, and then you can again descend back. Or you may, after reaching to that point, you can again contact to ATC, and based on that location inputs, ATC will give you the further, whether you need to continue at 20,000 feet or you can descend back to your original path of 15,000 feet. So that is how the ATC will guide you for safe flying. Okay. Any questions?
No, sir.
Okay. So yesterday we were talking about the VA loss. Okay. So cloud distance versus visibility. So imagine you are here flying your drone, okay, with your control station or a remote control. So from zero point 0.5 miles, from 5.5 miles, or you forget about the unit. Okay. You imagine this is a kilometer. 0.5 kilometer, your drone will be much better visible to you. Okay. But as it goes further, 1 kilometer, it will become little bit dimmer. Okay. The visibility will reduce of your drone. As it goes 1.5 kilometers, see, it will become very dimmer and dimmer. 2 kilometers, it will become almost unrecognizable. You will not know the orientation also of the drone, whether it is flying in what direction. Okay. Whether it is heading towards you, whether it is heading left, whether it is heading right, whether heading north, south, east, whatever direction. You can't, even if it is hovering at that particular location, you cannot recognize it. Okay, just by looking at drone. Okay, so 2 miles is the basic visibility. So in a standard condition, they are saying visibility is up to 2.5 miles in a normal condition, in a normal good conditions. Okay, 2 miles to 2.5 miles. Okay, beyond 2.5 miles, we can't see the drone. Okay, yeah. In place of drone, if there was a aeroplane, since aeroplane is so many times bigger than the drone, you can see, right? So depending again upon the size of the device, size of the aircraft, you will have the visibility of that aircraft. If you are flying a predator drone, maybe you will be visible. Your predator drone may be visible maybe up to 3 kilometers or 4 kilometers also, because it is much bigger than your normal small drones what we are flying. Correct? Any questions so far on cloud distance and visibility?
No,
Nothing.
sir.
Oh,
Okay, so now let's see what is cloud and fog. Cloud and fog both form when the water vapor condenses or freezes to form tiny droplets or crystalline air. However, cloud can form at many different altitudes, while fog only forms near the ground. Right? Now you see, the cloud and fog are both same actually, but cloud is always up in the sky, up in the air, whereas fog will always be lower to the ground. So that's why you see a lot of time fog happening in the winter season near the watery bodies, or in the valleys, or if you are gone to your native place, you will see a lot of time even near to your houses also fog would be there. So fog will always form near the ground, whereas cloud will always form in higher altitudes or higher height. So fog is defined as a cloud with its base at very near to the ground. So you can see the picture over here. Like when I went to Gurgaon for my master instructor training, I told you yesterday that the first 2 days I was not able to fly the drone, or we didn't have a training for first 2 days because of this kind of condition. So in this condition, I cannot fly the drone. Okay, it is very difficult and dangerous to fly a drone in this condition. So we are not able to see, even for distance of like 50 meters, I could not see the drone that point in time. So fog is caused by cooling. Air cools, it becomes denser and drains into the lower areas such as river valley, where thick fog accumulation may occur. Yes, Nishan.
Sir, are there any kind of remote controls where you have the screen, so even in foggy conditions you can, you know, look at the
FPV is there,
condition?
na? FPV, you can do FPV, but again, still that will limit your visibility because
Okay.
you will be flying in the fog. You will be flying in the fog, so hardly you will not see. For example, if you are flying somewhere here, see here you can't see the tree, right? You can't see the tree here, so it will be very difficult to fly in this condition. So ideally, you should not risk your drone. It is always said that whenever there is a low visibility, like a lot of time you see in the morning, like if there is a low visibility, they don't take off from the airports also. Okay, so they delay the flights. A lot of times your flight, why their flights are delayed? Because for a takeoff also a lot of time on the airport, because airport is a big open area. So a lot of time in the morning time it is a foggy. So a lot of time people will avoid flying in this visibility. Zero visibility kind of conditions. Okay, so fog caused by evaporation when cool air moves over the warm water. Enough moisture may evaporate from the water surface to produce starvations. Okay, so fog is also caused by evaporation when the cool air moves over the warm air water. Okay, so this happens in the sea. Okay, so a lot of time the winds from the westerly winds which we comes and flow over the Bay of Bengal. So there is the Bay of Bengal is heated water, whereas the wind which is coming from the northwesterly winds, they are flowing from the higher altitude, so they are more cooler airs. So that cool air when they forms, so you will see saturations happening at that point in time. Okay, and that's we evaporate the water surface to produce saturation. So that's why we see a lot of time because of this change in the temperature of the air. A lot of time we see in Bengal cyclones happening. Okay, so these are basically because of this all hot and cool air mixing with each other. You will see rains. A lot of time cyclone coming with the rains, or a lot of times we will see hurricanes and all that things happening and impacting Odisha, Andhra Pradesh, those kind of locations. Whereas compared to our side, like western side, Arabian Sea, we once in a once or 2 years, but that is never major impact of the of the weather on the western side. So Mumbai, we hardly would have seen any hurricane or anything happening like that in recent times. I think 2019 or 2020 we have seen that one cyclone was coming, but it didn't come to the Mumbai, though it was predicted that it may hit Mumbai shore, but it went towards Gujarat. Okay, so icing we talked about freezing. The rain is a common ahead of a warm front in winter. Serious icing occurs when the aircraft is flying near the top of the cold air mass beneath a deep layer of warm air. The raindrops are much larger than the cloud droplets and therefore give a very high rate of catch. In freezing temperature, they form a clear ice. So, lot of time you would have seen, a lot of air crash has happened because of this icing also. So similarly, if you are flying your drone in a like Punjab, Haryana, they normally face these icing issues. Okay, if your drone is lying in the field for a period, like in the morning when I went to fly a drone in a field, when I kept the drone there for even 1 hour, you will see icing happening on it. Okay, so you need to see that whether your drone is having icing. If there is icing, you need to remove that icing, or it will load your drone. It will increase the weight of your drone. It will probably impact the performance of your drone also. Okay, so similar thing is applicable when you are flying a fixed wing, especially in a fixed wing like Boeing aeroplane, Airbus aeroplane. These initially they had lot of crashes because of icing happening, and then they over the period they studied this pattern, and then they have deployed now de-icing functionality on the wings or on the body. So they are nothing but they are heaters. Okay, so they will actually activate the de-icing functionality. Automatically, the wings will get heated up, and the ice will what will melt, and it will vanish, and then you are safe for flying. Some aircrafts like Cessna has not been equipped with de-icing functionality, so they may request airport to send a tanker with hot water. Okay, so there will be a tanker coming with hot water, and then they will pour the hot water on the wings or on the fuselage of the aeroplane, and that's how the ice will melt, and then they certify the aircraft for flying safely. Yes, Nishan.
So there at times there are some specialized chemicals also, no, which they use inside the hot
Some
water.
chemicals are also used where it can melt the ice also. Okay, but then those are expensive solutions. Okay, heating is
Okay.
very easier, or compared to hot water, it is very easy to do it.
But
Again,
then
chemicals
why
are
they use
used.
chemicals?
Sorry.
If it is expensive, then why they don't use only hot water for
No, no,
big
it
aircraft?
depends. It depends on which location. Like chemicals, what you are saying is mostly used in European countries. Okay,
Yes,
because even the water doesn't become hot at that
correct, correct,
location.
correct.
So it takes more power, more energy you have to spend to get the water. Water. Okay, so that's why in those locations you have to use chemicals. Or best is the de-icing. That's why you see the bigger aeroplanes, commercial aeroplanes, they are fitted with the de-icing functionality. So there are coils in the wings itself, which will heat up your wings. Okay, the body of the metallic structure of the wing gets hot for a period of some period. Automatically, your that is the most simpler and easier method than any other method. Okay, so most of the commercial aeroplanes or aeroplanes, bigger aeroplanes, all these 747 or A380, 320, whatever these Airbuses, what we see, they all are been fitted with the de-icing functionalities.
Sir, later on, I would also like to know from you the difference and pros and cons of A380 versus 747.
अच्छा, वो
If you
ऑनलाइन
have
मिल
time.
जाएगा आपको.
Acha, okay.
Okay,
Okay.
okay, I will share you. I have some of them. Okay. So raindrops are much larger than cloud droplets and therefore give a very high rate of catch. In freezing temperature, they form clear ice. So icing is very, very dangerous. As of now, from a drone perspective, this is not much a matter of worry part, but this is only from perspective of aviation perspective we are talking about, because this there are a lot of crashes has happened because of the icing. Okay, lot of time even the sensors, your sensors get blocked by the ice, and you are not getting the right inputs to your sensors also. So that's why you also worry about icing. Okay. Lightning we talked. Lightning causes thunder, sound from a shock waves which develop as gases in vicinity of discharge. Sudden experience a sudden increase in pressure. Lightning occurs commonly during thunderstorm as well as type of energetic weather system, but volcanic lightning can also occur during volcanic eruption. Yesterday I gave you example of Indonesia, right? Indonesia has lot of volcanic mountains over there, so lot of sulfur is there in the air. So you will see a lot of volcanic lightning happening at that location. So mostly the flights which are coming from UK or then they're following the Indonesia path, they have to be little bit careful that point in time. So the when they approach, when they come from, they exceed what is this path? uh, northeastern state of India, normally they will fly over the sea. They will avoid the terrain part, okay, because in terrain part in Indonesia location, lot of volcanic activities is happening, and because of that, the air is little bit sulfuric over there. Okay, so it impacts lot of time flying of the aeroplanes until unless you have a landing in Indonesia or those locations, okay, Thailand or all those locations, then only you have to go to it. But normally, if your flight is going to Sydney, Melbourne, Perth, all those locations, or New Zealand, those locations, they will avoid the Indonesia path. Okay. Wind shear, or sometimes referred to as wind gradient, is a difference in the wind speed uh, and on or direction over a relative short distance in atmosphere. So you will see this wind shear, vertical or horizontal. So they are very for a short distance. All of a sudden, the wind will increase upward or lower direction. So you can see them also. Sometimes you can see this wind shear. The along with the wind, the heavy wind, the dust is also flowing in the air. Okay, the atmospheric wind shear is normally described as either vertical or horizontal wind shear. The vertical wind shear is change in the wind speed or direction with the change in altitude. So vertical is going up. Okay, so your wind speed will change and direction will change in the vertical direction. Whereas horizontal, it will just move horizontally across the Earth's surface. So horizontal wind shear is change in wind speed with the change in lateral position of the given altitude. Okay, so maybe at our location, the wind will fly, the wind will start flowing at a very high speed. Okay, that is called wind shear. Turbulence we have faced any given point in time. Whenever we are flying, we would have faced turbulence lot of time. Like I have, especially whenever I am flying from Mumbai to Delhi, I have seen that within that Jaipur region or that location, most of the time, I mean, if I have flown 10 times, 8 times I have seen the turbulence over there. Okay. So the turbulence, I have seen it. What is turbulence? It is a sudden violent shift in airflow, causes wind, storm, jet streams, object near plane, particularly mountain ranges. So if you are flying aeroplane like this, over the mountain, you will see the turbulence, the fast wind and the slow wind flowing up and down. So there will be change in wind speed. This can cause the turbulence over there. So there are multiple types of turbulence, three types of turbulence: normal, moderate, and severe. Okay, so that is called light, moderate, and severe. Okay, so in a light turbulence, your aeroplane may just go up and down by 1 meter. So it may be a little bit up and down. So it is a normal, nothing much worry. People will not even knowing it. Okay, you will just see a little bit shaky. Your aeroplane may be a little bit shaky. But in a moderate condition, it may rise 3 to 6 meters. So there is a huge difference in the height, altitude getting changed. Okay, so pilot will announce that okay, you may go back to your seats. Please put your seat belts and all the things. Okay, so lot of time the air hostess may also stop serving you, or they may not be giving you water or anything. They may stop. But if it is a severe turbulence where you can see up to 30 meters, okay, there's a huge difference in the aeroplane. So normally this time, this is a very very dangerous condition. So normally pilot will avoid getting into this kind of situation. So as they are approaching moderate, they will inform to the ATC and they will correct their course of path. Okay. Accordingly, the ATC will inform them either they have to roll right, roll back, or they may have to rise, or they have to gain the altitude, and then accordingly they can fly. Okay. Or if it is sometimes it is moderate only, so they can continue flying with it, but with some distance. Okay. If they feel that the turbulence is getting more severe and severe, then they may ask ATC to get the location changed, either height wise or horizontally. Okay. So moderate turbulence is similar to the light turbulence, but somewhat intense. There is, however, no loss on control of aeroplane. Okay. So with that, we complete the on weather and meteorology.
Nothing from me.
No, sir.
All good.
Right. All good, right?
All good.
What is the next topic? Okay. Next topic is drone equipment and maintenance. Okay. So you want 5 minutes break? We start at 4 p.m.
Yes,
That's good
works.
for me. Yes.
Yeah.
Okay, sir.
Okay, 4 p.m.
Okay, can we start?